We are adding another world to your chart. And if you filled in your chart the other day, you can see where this is going. We've got one kind of hypothesis test still to do. It's called a t-test. So we've done z-test, we did one prob z-test, and now we've got the t. And if you remember, the key to the t-test, the t-world, is that you are finding a sample standard deviation. So nearly everything on this worksheet is going to be a T. There's one that isn't, but it's all about S, which we'll spend more time talking about in the next couple of classes on how you're picking that. But so we're doing t-test. It's about sample standard deviations. Everything is going to set up just like it did. So you probably have the root idea by now, at least I hope you do. But what you need to get right is the details. So this is back to being about a mean. So all this repeats. So we did proportion. Proportion is the only one where a p replaces the m here. It's got to be an m, a mu. It's got to be there. And then you'll read through the problem and you'll find the sign for the other. So it's got to be a mean. And when you do the test statistic, it's now going to be t equals. This matters to me because the proportion world and the z world, they happen on a normal curve. It is exactly a normal curve. It's a perfect normal curve. It's beautiful, nice, exact. But when you're doing t-tests, because you sub this s, it is not a normal curve. It's close. It's very similar, but it's not the same. So I want you to see, by putting t equals here for the test statistic, that you understand that. This is not, a z is a test statistic on a normal curve. This is a test statistic on a t curve. I want you to understand that. And if you remember, the t keeps changing shape. Z doesn't, but the t keeps changing depending on the degrees of freedom, which is n minus 1. Okay, but here's my point. You don't need all that. It's just to see this. I need a t there. T equals, okay, because it matters. All right, so you're going to run all your tests just like you always did. But I'm going to throw you two little additional nuggets today. The first one is this. You can run a hypothesis test off a confidence interval under the right circumstances, at least for this class. And here's the idea. You're going to say, it's going to literally say, hey, run this hypothesis test as a confidence interval. It'll literally say that in the problem. I'd only put one of these on the test. So set everything up like you normally would, okay? Here's our null and alternative. If we're going to do this for the confidence interval for this class, it's got to be not equal to here. We got to have not equal. Okay, so we have not equal. Well, the second thing you got to do, the alpha level, and remember that if they don't tell you it's 5%, the alpha level needs to match up with the confidence interval. They need to be complements of each other. These go together to be 100%. Or if your alpha was 10, then you would want to do a confidence interval that's 90. They got to match up. It's got to be a perfect partnership there. Okay, now if you have that, and you run your confidence interval, now look at what you got. This is the exact same idea here. This is the only evidence that we have. It says 76 to 82 is where we think the mean is. Well, look at this null. 75 is not in there, so we would reject. 75 is not in there. It's the only evidence we have. Well, we reject. Now this is super simple, but it's got to meet these criteria. You got to have a not equal to, and your alpha level has to partner up with the confidence interval level. So an alpha of 10 would do a confidence interval of 90%. Okay, so we reject. He's not in there, so we don't think he's there. If it had been 77 up here, well, that's in there, so we'd fail to reject. And everything from that point is going to be the same. It's always about the top, so if we're rejecting, we're going with this bottom one down here. All right, so I got one last thing for you called a type 1 and a type 2 error. It just means this. We don't always get this right. The way this game works is, okay, somebody says the center is 75, so we put our curve there. Okay, you say it's 75, there it is. And we take a sample, we're way out here. Okay, well, we reject. That dot is too far away from where we'd expect it to be. However, there are dots out here. Sometimes you get a really bad sample. We're making an educated guess, but it's still an educated guess. It could be wrong. So I got a sample all the way out here and I reject. Well, what if that's the wrong thing to do? It happens. We're not God. We don't know the answer to this question for sure. So here are the two kinds of errors. There's textbooks always have this thing about innocent and guilty, and it makes no sense to me. It never has. So this is a simple way that you can understand what a type 1 and a type 2 error is. A type 1 error is this. This is the first one. This is the second. If you decided to pick the other one, you decided to circle the bottom, you've made a type 1 error. It was supposed to be 1, but you didn't pick it. Or if you wind up keeping the top, like you circle this when everything's finished, well, you've made a type 2 error. You picked this one, but you should have picked number 2. And if that doesn't all make sense to you, it's just as simple as this. Whichever one you circle, the kind of error you made is the other one. If you circled 2, you could have made a type 1 error. If you circle 1, you could have made a type 2. So it's just the opposite of what you circle.